Hi everyone, my name is Krishna Veni. I am working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management in Chemistry Department. Today I am here to tell about one important topic of the Unit 1 module, that is reverse osmosis. First of all, before going to know about the osmosis, this osmosis and reverse osmosis process is used mainly for the desalination purpose. What is meant by desalination? Why desalination is required? Desalination is a technique in which the salt water is converted into pure water. Means the name indicates the desalination. Desalination means removal of the salt from the water. Means the salt water is converted into pure water. That is called the desalination. The technique used to convert the salt water to pure water is the reverse osmosis technique. Why desalination technique is used means, in our country the pure water availability is very less. Everyone has to drink the pure water. They can't drink the salt water. That's why we convert the salt water into the pure water. That is the desalination technique. Now, desalination definition. Coming to the definition, the process of removing salts and minerals from the water in order to produce water suitable for various applications. Okay. Currently, how many desalination plants are available in India? 14,500 desalination plants are operating over worldwide, and 230 million people are working on this process daily. Okay, this is about the desalination definition and how many plants are working. 14,500 desalination plants. The number will be increasing every year. Okay, now coming to the osmosis and reverse osmosis. First, before going to know about the reverse osmosis, first we have to know about the osmosis. Osmosis may be defined as the process of moving water from low concentration solution to the higher concentration solution through a semi-permeable membrane. Means the movement of water from low concentration solution to a high concentration solution through a semi-permeable membrane. Here what is meant by solution? For example, any salt solution, if you take, means salt solution will contain solute plus solvent. Means a solution contains solute and solvent. Solvent is the major part, solute is the minor part. Means here the solution contains two parts, solute and solvent. Solute is the minor part, solvent is the major part. Okay. Here for example, in salt solution, the solvent is water. Means if we will take a glass of water, for example 100 ml of water, and we will dissolve 1 or 2 grams of the salt, means which is solute, which is taken in a small amount, and we will prepare the salt solution. Okay. Like this, in osmosis we will take the two different concentrations. For example, if you take salt solution of 0.1 molar and 0.3 molar concentrations, okay, these two solutions will be separated by a semi-permeable membrane. We can see here in the picture, here the semi-permeable membrane, here the fresh water and salt water is taken. Means fresh water means two different concentration solutions. Okay. When the water is moved from the side with higher salt content, here means when two different solutions, means 0.1 molar concentration and 0.3 molar concentration solutions are separated by a semi-permeable membrane, the water will move from lower concentration side, means the water will move from 0.1 molar concentration side to 0.3 molar concentration side. Means the water will move from lower concentration side to the higher concentration side. This is called the osmosis. Here the two solutions will be separated by a semi-permeable membrane. Okay. Now coming to the reverse osmosis. First we have understood what is osmosis. Here we will understand the reverse osmosis. Means in reverse osmosis the fresh water will not be available. We will take only the sea water, which we have to remove salt from it, salt and minerals from it. Okay. Means the water, here in picture you can see the water containing the impurities. Impurities means salts and minerals. Okay. And here also semi-permeable membrane will be available. But here what will happen, the water will move from higher concentration solution to the lower concentration side. Lower means here we won't take any fresh water, but for reverse osmosis one condition is there, we have to apply some pressure, okay, hydrostatic pressure, then only the water from the will be separated from the salts and minerals and the fresh water will be obtained in another side. Fresh water will be obtained another side. Here you can see the pressure is applied, the water containing the impurities, here the external pressure is applied, which is called the hydrostatic pressure. Then the water, only the water will move, fresh water will move to the another side. The condition is it will be separated by a semi-permeable membrane, means the salts and the minerals will be held in the semi-permeable membrane. It won't allow to pass the salts and minerals to the other side. Only the water, the fresh water will be passed to the semi-permeable membrane and we can collect it by outlet, fresh water. Okay. This is how the reverse osmosis technique, the mechanism of the reverse osmosis. Okay. Once again I will repeat. Osmosis means the water will move from lower concentration side to the higher concentration side when two different solutions are separated by a semi-permeable membrane. While coming to the reverse osmosis, here the water will move from the higher concentration side to the another side. Here the condition is we have to apply the external force, hydrostatic force. Means here the generally we will take the salt water. Why we are using the reverse osmosis technique? Here we are using the salt water, taking the salt water and we are purifying the salt water to get the pure water. That's why we are taking the sea water and the external hydrostatic pressure is applied. Okay. And this RO process is now used in the filters, RO filters in our households. So many filters today are available with RO technology. Means this is the technology in which the filters are been running. Okay. Means the reverse osmosis, it is called the simply RO process, a water purifying technology that uses a semi-permeable membrane. Here the semi-permeable membrane, the organic polymers will act as the semi-permeable membranes. Okay. Also called membrane desalination process. The reverse osmosis process is also called as the membrane desalination process. Salt water is forced through membrane sheets at high pressures. Okay. The salt water is forcefully, the external pressure is applied on the salt water so that the water will be coming out, leaving the minerals and salts in the semi-permeable membrane. Pressure applied depends upon molar concentration. Okay. The pressure, how much we have to apply, that will depend upon the molar concentration, means how much moles of the concentration of the solution is there. If the more concentration means more salts and minerals will be present, we have to apply more pressure. Membrane sheets are designed to catch salt ions. The semi-permeable membranes which are used in the RO technology is designed so that they have to catch, they will hold the minerals and salts in it. Okay. Here we can also see in the picture. Okay. Here reverse osmotic flow, the pressure will be applied. Here This is the semi-permeable membrane, green one. If we apply pressure on the salt water, the water will flow. This is the fresh water. Okay. This is the osmotic flow, means here the lower concentration, the fresh water and the salt water is taken. If we are not applying any external pressure, what will happen? The water will flow from low concentration side to higher concentration side. This is the osmotic flow. If we taken the adding the external pressure on it, the water will flow from high concentration side to the low concentration side. Okay, this is the technique and mechanism how the RO filters also will work. Today in our households we are using the water filters for purification of water, which will be worked on the RO process only. Okay. I hope you have understood this class. I have taken reference by Engineering Chemistry by Dr. B. Ramadevi, Department of Chemistry, JNTUH. Thank you.